So 2.11 was one of our trickier sections on the Unit 2 test, so this is a reteachable moment for you. If at any point during the video you want to stop and ask me a question, obviously feel free to do so if you're here in the classroom. But just some reminders before we get into the actual examples. Projectile motion kind of talks about what happens when an object is projected into the air. So it has to have some sort of increasing motion, reaches a max height, and then it falls back down, whether it falls to the ground or maybe to a person at a certain height. But it does take on that parabolic shape, which is why it has this quadratic function. And right now we've been just studying, if it's in feet per second, which goes along with this equation. So negative 16t squared, that will never change with our problems because we're always in feet per second, and that's like our gravity coefficient. VO is one thing. So VO represents the velocity the object is moving. So whenever we replace VO, it completely goes away. So I might have something like 6t in the middle. And that should be familiar because we've seen all these quadratic equations. We don't have these extra letters laying around. HO is going to be the initial height, so wherever the object is released from. It might be the ground, it might be somebody's height themselves, or like the top of a building. So the initial height always fills in the end of the equation. And I say you usually replace these two values because that's the information that you get right away from the problem. Now what you might be asked to do with that information, and not necessarily always in this order, is to find these different things. So maybe you're asked to find the time that the object reaches a particular height. So you're trying to find you're trying to find the time when you are given the height. So you replace that final height, the outside of the equation, h of t, and then you solve for your t. You might need quadratic formula, you might be able to factor it, complete the square if you want to get real crazy. If the object does reach the ground, if that's the final height, remember to use 0 as your h of t. Sometimes you might be asked to just find the max height, and so that involves needing to find the time that it takes to get there using the axis of symmetry. So to get a max height, you would need to know its input, the time it takes. So we find with this standard form, we have ax squared, bx, and c. We use our axis of symmetry equation, opposite of b over 2a. But instead of saying x equals that, it's our t, our time. So to get the vertex, that maximum point of a parabola, we first find how many seconds it takes in order to get there. So once you set up t, you'll know how long it takes to get to the max height, but then you have to go back and actually fill it into the problem for all those t values so that you can find the output, the max height. So you would replace t and square it, you'd replace t here, you'd already have your velocity filled in and your initial height. And so that's this last part here, find the max height the object will reach. So plug that t back in, find your h of t. So again, you might be asked to find time, you might be asked to find height at a maximum point, or you might be asked to find the max height itself. Okay. So round to hundredths when we're doing these problems, unless it says otherwise. So we're just going to go 2 decimal places, and don't forget about labels. You guys miss points for labels. So our first example, the time it takes a small rocket to reach a particular height can be modeled by a quadratic equation. We're going to let h represent the height of the rocket in feet and t the time passed after the rocket is launched in seconds, just like we were talking about above. The rocket has an initial velocity of 128 feet per second. Before I go any further, I know velocity is always the v coefficient, so the linear coefficient. So 128 feet per second is the velocity, and it's launched from the ground. So that would mean that the initial height is 0 because it's starting on the ground. So that helps me complete the function for this scenario. And now I need to find the time it takes the rocket to land back on the ground. So I'm trying to find time, which means I'm trying to find t, which is then in seconds. Now if I want to find t, I would have to know my height. So I'm trying to find the time when the height is on the ground, which means it's at 0, and it's back on the ground, so that's the end of the function. Alright, so if I want to find t, then I shouldn't be replacing it, I should be replacing height with 0. So final height, h of t is 0. plus 0 at the end of my function because I don't need to have a plus 0 in standard form. So now I can ask myself, what are some ways I can solve my function? This is a factorable problem. You could take out a GCF of negative 16t, and that would leave you with t minus 8 in your parentheses. So again, all I did was divide the entire equation by the GCF because both terms can be divided by 16 and both terms have a t. So if I look at my factors, t for the first factor would need to equal 0 in order for the whole equation to equal 0. My second solution would be t equals 8 for that part to equal 0. Now it was when it lands back on the ground, so 0, even though it makes sense that you can have 0 seconds, it doesn't make sense what they're asking. Back on the ground means it's already been up in the air. So that would be when it started at 0 seconds, it was on the ground like we knew. But now we know it took 8 seconds for it to get back to the ground. You could have used the quadratic formula here. If you did, make sure you plugged in that c was 0. You could have completed the square even, since 16 divided nicely out of 128. Completing the square would have been possible. Now our next question, what is the max height of the rocket and how long does it take to reach this max height? So the question is, what is the max height? Which really means we're trying to figure out the vertex of the parabola. Okay, so we're trying to find the max height in feet as well as the time it takes to get there. And that's still the vertex, so times in seconds. Vertex is our time and our height at that time. Alright, we already know the equation itself, so we just have the function as our given information to use so that we can apply the formula for a vertex. Sorry, I'm going to go ahead and erase that. I know that I can use the formula opposite of b over 2a to find the time, and then I'll need to plug it in to find the height given that time. And that will be all this maximum information. So let's start with opposite of our velocity over 2 times a. So our b was negative 128, and 2 times a would be negative 32. If you divide 128 by 32, you get 4 seconds. The negatives should cancel. So it takes 4 seconds to reach a max height, but we don't know what that height is until we plug in the 4 seconds. So we'll get this statement ready. So back to our function, negative 16, where times were 4, and we want to square that, plus 128 times 4, and then we have the plus 0 if we really want to include it. And when you calculate that, you should get 256 feet. So that max height, the highest it will go is 256 feet, and it takes 4 seconds to get there. Part D says, what if we were asked to find the amount of time it takes the rocket to reach 77 feet during its descent? And why is it important to note during its descent when finding the solution for time? So this rocket was off of the ground at 0. It had a max height of 256 feet, and then it reached the ground again. So this is one where it works out very nicely that the parabola is right in the middle. The x-intercepts are both possible zeros versus like having the negatives. Okay, so if we're asked to find the amount of time it takes to reach 77 feet, let's say that's here, that means there's 2 answers. And so that's why it's important that they point out during its descent. Otherwise you'd have to say, well, at this point it's reaching 77 feet, and at this point it's reaching 77 feet. So by clarifying during the descent, that would mean when it's falling back down, we only want that solution. And it's just like that first example we did after filling in the function. If we know the height is 77 feet, we want to find the time for t. And I'm not going to go through all of that, but just to see it set up, your final height is 77 instead of 0, like we usually do to say it's on the ground. And then your function, you can't fill in t
make sure that you do set the equation equal to 0. So you need to subtract 77 over into the rest of the equation. And now you can set up your quadratic formula, complete the square, whatever method you wanted to use in order to solve for time at 77 feet on the descent. And so when you got your answer, you would just want to make sure that it was after it had already reached the vertex, which was 4 seconds. So the answer you want has to be greater than 4 if it's already on its descent.
So that was just a little extra. And now I'm going to try to fit in these area problems. I'm running out of time on my video here, so bear with me. The rectangles and triangles are the only ones we've been practicing with, and we're not going to throw anything new at you for now. So area is length times width for a rectangle. For a square, it would just be length squared or width squared because it's the same thing. A triangle, you take base times height and you divide it by 2 to get the area. So we're going to be asked to find the dimensions, both the length and the width, for rectangular or triangular objects. Other than this example that I'm going to be doing at the bottom, we're going to still round to our hundredths if it's necessary, which is 2 decimal places again, and don't forget about labels. Alright,
So we have a rectangle has a length that word is should be like your equal sign. So a length that is 4 more than the width. So that would be W plus 4 more than its width. And we know that the area is 12 square inches. Well, we also know that area is length times width. And I need to plug in what I know so far. I know that length is W plus 4. So this is like substitution that we use with systems back in Unit 1 and even now in Unit 2. And I also know that the area is 12. So I have a couple things I can replace. Area is 12, length is W plus 4, and that's an entire quantity, so we got to keep it together as a group, and that needs to be multiplied by the width. You can distribute backwards, or you could rewrite this side of the equation to something you're more familiar with. W times W plus 4. Commutative property allows you to do that. Regardless, we're going to get W squared plus 4W on one side of the equation, and if we want to solve it, we need to subtract 12 because the quadratic needs to be set equal to 0 if we want to solve. So now I could try to factor. If I do W plus 6 and W minus 2, 6 times negative 2 is negative 12, and 6 minus 2 is 4. You could also use your quadratic formula. You could complete the square. Any of the methods other than the square root option would be good. So if I solve my factors, W plus 6 equals 0, that would mean negative 6 is the solution. But that doesn't make sense because width can't be a negative measurement. Over here, if W minus 2 equals 0, I can definitely have a width of 2, and our label here was inches. We know that from the area. So the width is for 2 inches. If I know an answer where 2 variables are involved, then I should be able to plug it in, the one that I know. So width is 2, which means the length would be 6 inches. And you can double check your area makes sense because length times width is in fact 12. And I've got about a minute to finish up with this one. So we have the height of the triangle is what we're trying to find, and it says to leave your answer in exact form. So if it comes out to a radical, we're going to leave it as a radical. And that's just so that we can practice our simplifying radicals. So the base of a triangle is a quarter of its height. There's a couple ways you could write that. A quarter would mean the height divided by 4, or 1/4 times the height, or 0.25h. I'm going to go ahead and use h over 4. They all mean the same thing. Area, we know, is base times height divided by 2. But I'm going to be able to replace base with h over 4 times h over 2. And I know that the area is 10. So this whole thing is equal to 10. H squared over 8 would be how I simplify because I multiply my h's and 2 denominators can be multiplied together. If I multiply 8 by 10 and square root, I get that the height is positive negative square root of 8.